All right, let's take a look at introducing functions and what defines a function and different ways that it can be represented. First, we need to go through a few little definitions. One is that a relation is a set of ordered pairs, and we have to remember an ordered pair has an x and a y, and we are set up this way. We also need to know that in that x and y that they have certain names. The x value is considered the input, and the y value is considered the output. And when we put all of that together, we understand that a function is an equation where the input has a one-to-one relationship with the output. So we can almost think of it like a function machine. And what a function machine does is basically tell us that as one thing goes in, as we put that x, something happens to it within there, and we're going to get an output. Now, as long as we get one thing coming out, that's going to give us a function. If we get more than one thing coming out from that one input, we know it's not functioning. And the word function means that it works. It's something is functioning, it's working. If it's not working, if we're not only getting one thing, it's not considered a function. So let's take a look at some diagrams and see if we can determine what's a function, what's not a function. So here we have, in this example, an input of A, B, and C, and an output of 1 and 2. And the lines kind of tell us what's going on. So as we input A, output is 1. I input B, output is 1. Input C, output is 2. So each time one thing goes in, only one thing goes out. Because of this, we say that this is, yes, this does represent a function. Yes, this is a function. And because it shows a 1-to-1 relationship. Okay, and we have to explain why we're saying what we're saying. Okay, we're going to say this is a function because it does show a 1-to-1 relationship. Let's take a look here at another one. Here we have A, B, and C, again, with an output of 1 and 2. Here we have an output of A. Well, A is shooting out a 1 and a 2. B is shooting out one thing. A C is shooting out only a 2. But because of this A is shooting out more than one thing, it's not a 1-to-1 relationship. So no, this is not a function, because it does not show a 1-to-1 relationship. Okay, so that's kind of what we're going to be looking at and trying to define it by that. Let's take a look at one more. Here we have the numbers 1, 3, 5, and 7, and the numbers 2, 4, and 6. We notice that the numbers on the left of this diagram represent the inputs, and on the right represent the outputs. And hopefully by looking at this, we can acknowledge that yes, it is a function because it shows a 1-to-1 relationship. Okay, so now let's take a kind of a look at it more so with looking at graphs. So before we get there, let's talk about the vertical line test. So when we talk about the vertical line test, when we're looking at a graph, if it only hits in one spot and one spot only, it's going to mean that it's going to pass the test, that it passes that 1-to-1 relationship. So I'm going to show you how that works. If we're looking at this particular set of ordered pairs, 3, -4, so 3, +3, -4, 0, 2, and 5, 1, we can see, just as we know that the X represents the input, as we go along the line, we see that as we encounter only one output as we go along. So because as we go as an input and output and only one thing happens, we can say that yes, this is a function. We could also line up our pairs to show the relationship. And we can see, just like before, how there's only a 1-to-1 relationship. Now, a moment ago, I mentioned the vertical line test. If I take this vertical line and apply it here, as I put it across, as I move it across, we can see it only encounters one point at a time. As long as it encounters only one point at a time, it also passes. So we're going to write down that yes, this is a function. And we're going to say because we could continue with our original reasoning because it shows a one-to-one relationship, or because it passes the vertical line test. So we have a couple reasons now when we're showing it to ourselves graphically here. We know if it passes the vertical line test or it shows a one-to-one relationship that it is a function. Okay, let's try it again here, and let's take a look at these 3 points. Negative 3, 2, negative 3, 5, and negative 3, 7. Now, we could see, as we were talking about a moment ago, as we go along, right, what happens? Well, as we go along, we're getting 3 numbers shooting off out of our output. Our input was 1 number and output was 3 numbers. So, and we can kind of see what's happening. We're saying, hey, it's negative 3 here, and I get 2, 5, and 7. I'm getting all 3 things off of 1. Well, if that's the case, and again, let's bring in our vertical line and see as we pass it, we can see that all 3 points will land on it. So we know that this is not a function because it does not show a one-to-one relationship, or it does not pass the vertical line test. So those are we just need one reason, but that gives us 2 reasons and shows how that works. Let's take a look at a bunch of graphs and determine if they're going to pass the vertical line test or not. We can see with this graph right here that it does. It only is going to hit at one time. Here, when we look at this graph, we can see that as the vertical line goes through it, we're going to be hitting it twice. And if we think about it in terms of what we just talked about running into things, we can see at 2, we would have ran into 2 numbers at negative 2. So that would show that how this is not applicable. Let's take a look here. And again, we see it does pass the vertical line test. It only hits it in one spot. Here's another one where again it is only hitting in one place. And one more time, it's only hitting in one place. So we can see how the vertical line test works. Let's take a look at taking a look at a graph and being able to create from the graph our inputs and outputs. So here on this graph, we have some points, and I'll darken some in here for us. And we'll use these points as our input and output. So if I look along the x-axis, which is here, we see our input of negative 1. Well, at negative 1, as an input, we know that our output is 3. At 0, our output is 2. At 1, our output is also 1. And at 2, our output is 0. And we could go on and find more points on this line to add, but we'll just do those 4. Now, when we're looking at this, let's talk about writing a rule, just briefly. Okay, what we're talking about is that, just like I said earlier about a function machine, okay, we're going to put something in to here, and something's going to happen to it. We're going to put that negative 1 into the machine, something's going to happen to it, now it's going to pop 3. I'm going to tell you right now what that's going to be, because it's kind of hard to tell by this, because this one's a little complicated. If we took the input, whatever it is, and multiplied it by negative 1, but then added 2 to it, this will pop out. We'll test it and see if it works. Let's take this negative 1. Put negative 1 in. Negative 1 times negative 1 is positive 1. 1 plus 2 is 3. That's what had happened. Let's put in a 0. 0 times negative 1 is 0. 0 plus 2 is 2. That's what came out. Let's do 1. 1 times negative 1 is negative 1. Negative 1 plus 2 is 1. And one more time. 2 goes in there. 2 times negative 1 is negative 2. Negative 2 plus 2 is 0. So we can see we can use this rule to continue on. Let's just practice one more in finding the input and output by looking at a graph. So once again, here we have a graph. And when we're looking on here, we want to make sure that we're taking points that cross exactly in the crosshair, so to speak. We could do this one, but then we're going to be estimating how much that one is. So we're going to be looking for points that are exactly right on the crosshairs of the graph paper, because those are easier to use because they are integers. So let's take an input here of -3. At -3, it's going to be 0. At -1, it's going to be +1. At +1, it's going to be +2. And at +3, it's going to be 3. That's where we're going to stop, and hopefully you have a better understanding of how an equation can represent a function.